Things, muchachos. Well, Plum's asleep. Shh. Plum's sleeping. Lights are off and nobody's home. And that's because I have nothing really to show you anything new over here, unfortunately. What I have been working on is this over here, which is a new memory unit, a new memory module for Plum to replace its rather measly, oh dear, I've dropped my pointing stick, measly 16 byte with its 4-bit address register, and we'll replace it with this whopping, oh dear, pick up my pointing stick, this whopping great big 64K memory unit with a 16-bit address bus. Yeah, nice. However, I'm afraid I can't show you it working because it doesn't really. I mean, it kind of does, almost. With the 3 layers of wiring here, 1 layer, 2 layers, 3 layers, I am honestly shocked that this turned out to even be wired correctly in the first place, which it was. And I'm amazed because I could not see, trying to force these wires through 2 layers of wires. You cannot see what breadboard holes you're poking the wires into. So I'm kind of amazed that I didn't cross any by accident. That was pretty good. However, there is a slight stumbling block with these that I'm currently in the process of trying to overcome, and that is that let's keep the shadow out, both the write enable there and the output enable are both active low. Now that's fine, there's nothing inherently wrong with that. However, with the way that I've been doing everything so far with these sort of D-type flip-flop octal register doodads, both those ones with the reset line and these ones with the internal tri-state buffers. Problem is, these will all output on the active low, but they will write into themselves on the rising edge of the clock signal. So the clock goes up and down and up and down and up. It will only ever write on that up. During the up period, it won't continue to write if the input changes. It just on that instant that it rises. And that's okay, because essentially what's happened is I've got 2 phases of the clock cycle. One when it's going up. I suppose one where it's going down and one where it's going up. So when it goes down, we set up for the next clock cycle, and when it goes up, we lock in all the new values, and then we drop down again and we start outputting new values, and then we come up again and lock in new values, and that's worked so far. Trouble is, where these are both active low, it's not so easy to just feed the clock signal straight into there, or to do like what I've done here, which is essentially depending on which register you select that you want to write to, we route the clock signal to one of them. The clock signal doesn't always go to all of them, it only ever goes to the one that you want to write to, which, I think kind of makes sense, and it has worked so far. But I can't do that. Well, and that's what I've done over here as well, except on this one, that's the grey wiring. Thing is, I can't do that over here because the write signal is active low, and it's active low on the falling edge. So essentially, the memory wants to write at the same instant that everything else starts outputting. The memory wants to consume a number from the data bus at the same moment that the registers are still putting it out onto the data bus. And obviously there are gate delays and propagation delays and all that kind of thing, which I'm probably not really experiencing a great deal of at the moment because I'm running this so incredibly slowly. But it's something that you want to keep in mind and will come up. So I need to, what I'm intending to do is on this module to essentially expose the same kind of interface that this memory module would expose, and that is a bunch of bits for the data, or the memory address, and then a signal somewhere. Yeah. So clock would come in there, and I can't rightly remember where output goes, but it's somewhere. So essentially, there is a active low signal, continuous active low signal for outputting. Oh no, yeah, of course that goes here. Like every other module, the active low signal for output is here on this sort of this bus buffer. So we bring this signal, this yellow signal here, low, and that outputs whatever's on this blue bus out onto the white bus, which does have the effect of kind of feeding it back in, but that's fine. And that outputs it onto the data bus, and away we go. So there's an active low signal for that, but then the clock signal, this is an active high signal. So we can output, and then while that's outputting, we could bring this signal high, or just hit the button. I can't do it. There we go. And that would pulse this grey line high, which then goes into... what are these? These are ANDs, I think? Something like that. Anyway, basically it checks which of the chips has been selected using these these two 74HC138 3-bit to 8-line decoders, and mixes that in with the clock signal, and that then feeds an active high pulse to one of these chips, and on the rising edge, the chip reads from the input, which in this case is the white wires, and locks it into the chip on the rising edge. So that's what I need to do for this over here. I think that's going to be the most straightforward thing, is if both of these memory units had exposed the same kind of interface to them. So I want one active low signal to tell the memory module to output onto the data bus, and I want an active high, a rising edge active high. No, I suppose it's a bit redundant. So just a rising edge signal to tell them to write into themselves. So yeah, I mean, I don't know. Actually, yeah, I think I've got the data sheet here. Let's just have a look. That's the one. There we go. I don't know how well you'll be able to see this, but here's the timing diagram for the write cycle. And you can see, first off, we put an address onto the address bus. Then we bring the chip enable lines low and high at the same time. So we've got an active low chip enable and an active high chip enable. That just makes it easy for us to link them together and that kind of thing. So we assert an address on the address bus. We make the chip active. Then some point after that, we need to pulse write enable low, and then bring it back up and deselect the chips. And this is the pulsing that I currently need to do, but I need to change a rising edge pulse into a falling edge pulse, and that is pretty straightforward. I'm pretty sure I've done that in something over here. There was something I needed to invert the clock signal. That's all you really need to do, but obviously I want to do it in a ludicrously tidy manner, so this module has been a little bit of a source of frustration because it's so difficult to do things tidily in it. I'm basically just going to have to live with this kind of arrangement for jumping the signals in and out of the memory module. The other thing is that I've got more of these braided wires that I've been making, and they are really nice to have and really nice to use and move around, and I'm a fan of those because I can just connect and disconnect a whole bus pretty quickly. However, it is kind of more reliant on having all your pins in the right order. Yeah, that then kind of breaks this pattern that I've got going on here for these buses. So I've been that's why I've at the moment these are 74HC245s. Is that right? Yeah, 245, and they are bus transceiver chips. So they do basically exactly the same as these buffer chips do, except you can set which direction you want them to operate in, and all the pins, the A side and the B side, are all in order. So it's 0 through to 7, or maybe it's 0 through to 7. I'm not sure, but either way, they're all in order on the same line, rather than over here where they're kind of all alternating in their direction. And on these the direction is fixed, whereas on these they are bidirectional, and you can use this pin here to set the direction. So I'm going to need that for this, because this is the data bus, and I do need to be able to get the value in and out here. Now I can just leave this the data bus hooked directly to the chips, which is why these wires are white at the moment, because it is data bus. However, when I was playing around with it and debugging it and had it all connected up, I was finding it a little bit annoying that I couldn't preview the value that was being stored in the memory before outputting it onto the bus. I think just visually I would like to have that, and it adds a few flashing lights to the module, which is fairly devoid of lights at the moment. So I think that would be... I would like to do that. I would like to be able to preview the data coming out. So yeah, I got that, and I'm thinking of using them here as well, just because once I was using those two registers as the memory address register. As you can see, I've got these additional wires that I've made, and they just jump in there, and that works fine, except I had to remove the LEDs from either that side or this side, one of the sides, just because they were you could tell that the current draw was getting high, because well, they were just getting dimmer and they weren't working so well. I suppose it was the combination of red LEDs and green ones paralleled up to each other. So again, it would be quite nice to use the buffers just to isolate the modules from each other a little bit. So I'm having a play with that at the moment, and yeah, desperately umming and ahhing over chip placement and where to put everything in an optimal manner. You may observe that I've also skipped out a power rail here, and I've also skipped one out here, so this is a relatively unusual module for me, in that they're kind of two double-sized breadboards at the moment. So we'll see how it goes. But yeah, that's where I'm at, and I'll keep you posted. I think the next video may be more screencasty, because I will try and get to work finishing this up, sort of, and then we'll have some software to look at. So yeah, Plum is progressing, just progress is slow. Also because it's summer and I've got my garden going on, so I'm not spending any weekend time working on this. This is only during the week while I'm up in London, so I'm maintaining the garden on weekends. So may even post some videos about that. It's quite good. Very therapeutic. Anywho, that's 15 minutes. Have a good one.